Welcome to Aseem Dnyan Vahini. The acronym for Aseem, A-S-E-E-M, Atmanirbhar, Science, Education, Enrichment, Mahavahini. Aseem Dnyan means unlimited knowledge. Aseem is for empowerment of educating skills. Aseem is for organization of science quiz contest. Aseem for science education short film festivals. Aseem for reviews on various famous science exhibition. Aseem for talk shows on science related topics, for great meet with famous scientists, and Aseem for webinars and lecture series. The ultimate objective of Aseem Dnyan Vahini is science popularization.
The NCSC 2020 was held online. In this year 191 projects were registered for first level of Mumbai District Children Science Congress. On the basis of Synopsis evaluation test of all these 191 projects, 102 projects were selected and called for project video and project report book evaluation round. From this round 65 projects were selected for live oral presentation at Mumbai level, from which 20 projects were selected as best projects from Mumbai and were sent to state level. We feel proud that our project was among the selected projects for state level. On 31st of January 2021 we presented our project for state level on Zoom meeting. I am happy today to present the same video here in front of you. Aseem Dnyan Vahini is presenting the series of these 20 videos. This is our small step for science popularization and for documentation of good projects for future child scientists.
Good day to one and all. I, Nagara, the group leader of the project titled The Effects of Magnetized Water and Magnetic Field on Seed Germination, Growth and Production of Food Crops. The theme of the project is Science for Sustainable Living and sub-theme is Ecosystem for Sustainable Living. We move upon to aims and objectives. Aim: to study the effects of magnetized water and magnetic field on seed germination, growth and production of food crops. Objectives: first, compare the rate of germination in experimental plants. Second, to compare the growth under magnetic field and control. Third, to determine whether the magnetic field can influence plant growth based on the observational data. Fourth, to identify the parameters of the plant growth affected by magnetic field. Fifth, to observe changes in the plant growth after the magnetic field is removed. Now we move upon to hypothesis. The entire project is based upon the hypothesis that magnetic field has significant positive effect on plant growth. Second, if plants are grown in an environment with magnetic field, they will grow much better than without magnetic field, example control. Third, plant seeds under the influence of magnetic field have a higher examination rate as compared to control. The height of the plants grown under the magnetic field should be taller than the controlled one. The width of the plants grown under the magnetic field should be healthier as compared to control. The leaf color of the plants grown in magnetic field should be fresh green as compared to control.
Methodology and experimentation. 3 round plastic pots with a diameter of 15 cm and the height of 12 cm were filled with the soil mixture in the ratio of 3:1 for each experimental plant. The seeds of moong and chana were allowed to germinate in 2 parts. First, magnetized water and second, plain water. Before sowing the seeds, 1 ring magnet was placed in the center of 2 pots and the third pot was maintained for controlling for both experimental plants. Plant seeds were sown 1 inch deep inside the container. 20 seeds of moong and 10 seeds of chana were taken so that there is an equal distribution among the circle in the diameter of 15 cm. Each pot was placed near the window and exposed to sunlight in the daytime. The plants were grown under room temperature. The soil in each container was kept wet by watering them every day once so that the soil surface is not too dry nor soggy to the touch. The plants were observed for 4 weeks. The magnets in the third pot were removed after 2 weeks. But the observation continued till the 4th week in an attempt to evaluate the magnetic effect on the plant growth.
Data analysis and interpretation. The plants were grouped as follows. Treated 1. The plants were grown under magnetic field. Treated 2. The plants were grown under magnetic field for 2 weeks only. Control. The plants were grown without magnetic field. Rate of germination in moong plant. All seeds germinated after 4 days in treated 1, 15 out of 20 seeds germinated in treated 2, and 13 out of 20 seeds germinated in control after 4 days. Average height of the plant after 4 weeks, 20 cm in treated 1, 19.5 cm in treated 2, and 18 cm in control. Average length of the third leaf after 4 weeks, 4.14 cm in treated 1, 3.9 cm in treated 2, and 3.8 cm in control. Width of the plant 1.2 cm in treated 1, 0.8 cm in treated 2, and 0.5 cm in control. Color of the plant of the leaf. No yellow leaves were seen in treated 1. Few plants showed yellowing of leaves after the removal of magnet in treated 2. Some plants showed yellowing of leaves in control. Rate of germination in Chana plant. All 10 seeds germinated in treated 1, 6 seeds germinated in treated 2, and 5 seeds germinated in control. Height of the plant 16.14 cm in treated 1, 12.01 cm in treated 2, and 11.76 cm in control. Width of the plant 2 cm in treated 1, 1 cm in treated 2, and 0.6 cm in control. Color of the leaf of the plants. No yellow leaves were seen in treated 1. No yellow leaves were even seen in treated 2, and only few yellowing of leaves were seen in control.
Conclusion. The results showed that the plant seeds under the influence of the magnetic field had higher germination rate, and these plants grew more higher, taller, and healthier than those in the control group. No harmful effect of magnetism on plant growth was noticed. However, the removal of the magnetic field weakened the plant stem, and thus suggesting the role of magnetism in supplying energy to the plants. Suggestions. The exposure of plants to magnetic field is one of the potential safe and affordable physical application for enhancing the crop productivity and to improve the quality and quantity of the food production in greenhouse or field conditions. This technology does not emit waste of any kind, nor does require power, and it does not also produce radiation. So it is environmentally, economically friendly, highly sustainable for modern agriculture and sustainable method. Future plans. As the study comprises of 2 plants, in our further studies we would like to monitor the effects of magnetism on other food crops as well. In this study we have considered few growth parameters of the plants. In further studies we would like to consider the physiological parameters also, which includes the carbohydrate content, fat content, and protein content using suitable experimental techniques. The intensity of that magnet is unknown in this study. Thus, in future studies, we would carry out the experimentation using magnets of different intensity and find out the intensity for the better plant growth. Thank you.
Thank Ministry of Science and Technology, New Delhi, NCSTC Network New Delhi, Jigyasa Trust, Thane, Navnirman Vigyan Prabodhan, Mumbai, Education's Inspectors of South, West, and North Mumbai for their support and guidance.